Hello everyone. So we left something from B2, the real numbers. So here B2 real numbers. The B is capital, B2 real numbers. Okay, so the last things we left there is the intervals, sets and intervals. I mean sets and intervals. So I'm going to give fast review. Here's the review. So last time we talked about A, comma B. To make a table, small table, fast table. 1, 1, 2, 3, 4, 5, 6. We need 6. 2, 3, 4, 5, 6. Here's the set. Here's the set description. It's not here. Here is the set description. This is the notation here. A, comma B. The set description. This is the set description means all value x such that x between A, comma A and B without the equal. We don't have to write the equal. Why? Because I mean for this notation, all values between A and B without including the endpoints. The endpoints are A and B itself. So I mean here all values between A and B. So the graph for this one is look like this here. Small line from A, open circle or open ball. This is A, and B, the same things is open ball because they are not included. So here, the line between A and B. Okay, the same things for the notation. The close interval from A, set description is x such that x between A and B, such that A and B are included. Why? Because this is closed interval. I mean for a closed interval, it's all the values between A and B and the endpoints. The endpoints here are A and B themselves. So here I can graph it as same like, so here I have closed ball, close at A. I mean not ball, a closed circle because they're looking like circle. So here, so and there is the line between A and B connection. The third one is half close, half open. So it's look like this: half at A is open and at B is closed. So all values such that x between A not equal and B equal because B is in the interval. So the same things, I graph a line, and at A, it is open circle, open, so it's open. At B is closed, and there is a line between A and B. Here is B, here is the line. The third one is from A to infinity, A, comma, infinity. So again, all values from A goes to infinity. All values is greater than A, from A to infinity. So this is again X here. Here is the X, so is close smaller than X, and close this description. So here's the line. So it is open here. This is A, and all values is greater than A. So I have rows here, like this. Okay, and we have another one is from minus infinity. Yes, this is the symbol of infinity. Jasmine, is the symbol of infinity? Yes, this is the symbol of infinity. Okay, so from minus infinity to B, at B is closed, so means that the values from X is less than or equal B. Okay, so here I have line, the same things. I mean here for all values less than B, like starting from B and goes down. So you can set here a close circle at B, and I have arrows like this. Okay, please fill the attendance. Ala Salah, she posted. So again, please fill the attendance. Thank you, Ala. And Yelene also, thank you. So the last notation is this one is from minus infinity to infinity. This is mean all values X such that X belong to the real numbers. I mean for that, all values, all real numbers. So again, here is the line. And I mean for that, all values look like this. All values, the line one, and I have also arrows like this from this side and the other side. I mean for that, all values. Okay, so now let's give me an example. So after we know this notation and the set description and the graphs, we're going to give small example we left it from the previous class. Any question for this, for the review?
No.
No questions? Okay, I hope they are clear. So here example, small example. I'm going to start, for example, for set. So suppose I have a set. I'm going to do it in the next slide. Can I move to the next one? What about the others? Can I move to the next slide? Okay.
Yes.
Okay. So the example look like this. Here is the example. Suppose I have 3 sets. So the first set, if s equal from 1 to 5, 1, 2, 3, 4, 5. And the second set is t equal 4, 5, 6, and 7. The third one is v equal 6, 7, and 8. The question is find find the value of S, I mean the set of S union T. So to find the value in the set of S union T, it's supposed to be all values, all elements, I mean, all elements in the set S or the element of the set T or both of them. Okay, I mean, for that, I have to put all elements of S is 1, 2, 3, 4, 5. Then I go to the set T. Here is the set T. I have to put all of them inside this union set. The four already we borrowed. We don't have to borrow it again. The 5, the same things. 6 is new. We have to write it down. And the same things for the 7. So this is the set of the union of S. This is S and T. So you have to put all elements of S, then you have to put the all element in T, but if there is a common between both of them, you don't have to write it again. For example, the 4 we write it down, you don't have to write it again 4. Second one is the intersection. Find S intersect of T. Here I get the question, just added the non-repeated number basically. Yes, this is exactly. You don't have to put the repeated one. Just you put the first set and you put the second set, but if there is a repeated element, you don't have to write it again. For the intersection, you have to find the common element between both sets. For example, S and T here, as we see, there is S and there is T. What is the common element between S and T? If we look into the 1 is not a common between S and T. The 2, the same things. The 3 is not common. But the 4, if we look into the 4, it's a common element between S and T. So this element belongs to the intersection. So this is here 4. The 5, what about the 5? Yes, the same things, 5. And that's it. So the intersection between the two sets is the common element between both of the sets. What about 8 from set V? No, we're doing only for S and T only. Jasmine, we're doing only for S and T. Yes, this is intersecting. Between S, this is S, and this is T. Now, for the third question is find S intersect V. What is the values? What is the set, I mean? The same idea, we're looking for the common element between the set S and the set V. So if we're looking into the 1, we cannot find anything, any common between 1. 2, same things, is not a common. 3 is not a common between the S and T. 4, the same things. 5, the same things. So actually, we don't have any element. So it's empty set, or we can define it as equal empty. Empty. Make sense? Any question? Okay, this is for only sets. I'm going to give examples for also interval, but you have to know the idea about sets first. So here is it clear, right? Now, example for interval. So the second example, if you have a question, you can stop me. Okay, the example is graph. Yes, this is a Webasani question here. A graph each This is a over sign here. Graph, or I mean similar to the over sign. It's not exactly the same, but similar. Graph each set. If I have interval from one open interval 1 to 3, intersect the closed interval 2, 7. Okay, to do this one, we have to graph. So how we do it? So first things, you have to write down the graph the interval 1, 3, the open interval from 1 to 3. The graph for this one, like here, is the same like this one, the first one. The graph for the first interval, the open interval, is exactly like this one. So let's graph it. So here is the graph. I'm going to need another graph for the second one and final graph here for the answer. So the graph for the first one, the first interval from 1 to 3, open interval, it's look like at 1 is open, here is the 1. At 3, is it here? It's here. This is the 3, open. And there is a line between 1 and 3. Okay, for the second one is the closed interval 2 to 7. So at 2, the 2, it's look like between 1 and 3, right? So it's gonna be like here, and it's closed. Again, the 2 is between 1 and 3, so it will be like here. You go down, will be here. This is the 2, and the close. And also the 7 is after the 3, so it will be like not here, like around here. Close. So this is 7. And there is a line between 2 and 7. Here is the line. Okay, so now the intersection, all common elements or values between these two intervals. So the common values is look like here is at 2 is a common values. It's a common value between the two interval, and all these values here until 3, only until 3. And the 3 is open because it's open in this one interval and is closed here. So this is not common value between both of the intervals. So I can set here at 2 is closed because it's a common between two interval. So here the a comma 3 intersect 2 comma 7. The closed interval is at 2 and goes down here until 3, and at 3 is open. So this is the intersection interval. This is the value or the answer. So the answer, it will be like, so here I can say is equal close at 2 and open at 3. This is the answer. Any question? Is it clear? All good. Okay. Another one for union. So we do this for intersection. Now we're going to do it for union. So here the example, another example. So can I move to next slide? If you have a question, you can ask. Okay, let's go it. Now, example number 3 is the union. So example here, the same set, the same interval like before. Find our graph 1,3 union at 2 to 7 close interval. So again, 1,3 is like before, the graph like this one. So I'm going to graph it again. At 1 is open, and at 3 is open. Make it more smaller. This is 3, and there is a line between 1 and 3, like this. Okay, this is here 1, and here is 3. Same things for the second one, second interval, close interval from 2 to 7 is close. So I'm going to graph it like the previous slide. At 2 is close. This is 2 here. Close. And at 7 is close to. So the 7 after 3 will be here. This is 7. And there is a line between both of 2 and 7. There is the line. Now the union, like I said, all elements in the first interval or in the second interval or in the both of them. And again, no repeated. So I can say here 1,3 union 2,7, close interval would be, we have to graph a line. So you're starting at 1. So you go down, graph here, you go down at 1 because we need all the elements. So at 1, you go down and you graph the 1. Like you graph exactly the same, this interval. And you graph the 3 again here. And there is a line between of them. This is a 3 here. And again, you graph this one, is 2, above this one. And you graph the 7, the point 7. And draw a line between of them like this. So after you passing the 3 will be closed. We close this point. Why? Because we pass it. So the final graph after all this is the final graph. Let me use the black one, black line. So this is the final graph. At 1 is open. Here is the 1 is open. And this is a close. We close it because 2 passing the 3 here is a close, and here is open. So we close it because it's inside the interval. And at 7 is a close. So the graph, the final graph is from 1 is open to 7 is a close. This is 7. This is called final graph. So this is the answer, the final graph. So the answer is the open interval from 1 to 7, and at 7 is a close. This is the answer. Any question?
What does the U mean, like in the middle of it?
Union? All elements in the first interval or in the second interval or in the both of them. Here we have to put both of them. So you have to graph the first one. This is the graph for the first interval from 1 to 3. I graph it 1 to 3 and open at 3. And I graph the second one in the above of this one. So after we pass the 3 will be closed because the second one on the top of the first one. So it's closing the 3. So the final graph, we graph the same things like this one, but we make it like more clear. So at 1 is open, keep it open. At 7 is closed, and the 3 is closed. So it will be like from 1 to 7.
Okay, I get it. Thank you. Can you go
No
back to the previous slide for a
problem.
second?
Previous one,
Yeah,
this one. Okay.
thank
Anyone
you.
has a question for the other for the this example? Anyone has a question for this example before we go to the previous slide? How do you know where to put the exact point, or it's just a guess? It's not a guess. So here, first one, when I graph the first one is 1 to 3. The second one is from 2 to 7. So the two, we know the 2 is between 1 and 3. So the graph will be 2 here, this point. So you graph it in this point. And the 7, I know the 7 is greater than 3. So it will be like more after 3. So it will be here. So when you graph the union, you graph the first one, and you put the second one in the top of the first one. So you put the second one in the top of the first one, you close the 3 already. Jonathan. Yes, Abu Bakr. This is correct. Okay. The line is not like Abu Bakr, he said, is not labeled. So you have to guess, or I mean, not guess, like you put approximating, this is like 1 and this is 3. Okay. You approximate, this is 1 and this is 3. But the important things, when you graph the second one, you have to put the 2 between 1 and 3. This is the important things. And the 7 after 3. Okay. So I'm going to the previous slide. So by these two examples, I mean, all these examples, we finished this section. Now I'm going to the next section. After you finish writing, please let me know.
Okay, I got it.
Okay. Now, so the next section is talking about exponent.
Wait, can you go to the previous slide just for like 2 seconds?
Okay, this one.
Yeah, 1 sec.
Okay.
All right, you can go back.
Okay. Here, P3 is integer exponent. Integer exponent. So again, for student who came late, fill the attendance sheet. It's in the chat box. Okay, exponent, integer exponent. So suppose I have a product of identical numbers. I mean, for that, if I have 5 times 5 times 5, so this is equal actually 5 same number here to the power is the number of how many times I multiply each of them. So I get 1, 2, 3 is equal 5 to the power 3. And you have to know all this number are identical numbers. Identical. So here we do a product of identical numbers. So we do product of identical number. So when we multiply, for example, the 6 4 times to each other, 6 times 6 times 6 times 6, this is actually equal 6 to the power 4. So 6 times, for example, 6 times 6 times 6, this is equal 6 to the power 4. How many times I protect the 6 to itself? Okay, so in general, I can make it this as general formula. In general, if A is real number and n is positive number, so A to the n, so I'm going to define this one here. So A to the n is equal A times dot 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 times A n factor. This is n factor or n times n factors. I mean, I have to multiply this number A n times to itself. Okay, for example, and before we go to the example, this A here, the A is called the base. And this n is called exponent. Just definition, exponent. This is just a definition. So A is called base and is called exponent. So for example, for that, here is example. 1/2 to the power 5. What is that equal? Who will do it? What this equal?
It's going to be 1/2 times 1/2 times 1/2, and it is 5
How many times?
5 times.
5 times. Yes, this is correct. So this is equal 1/2 times 1/2 times 1/2 times 1/2. 5 times 1, 2, 3, 4, and again one more 1. And the answer is when you multiply, like previous lecture, we have multiplying fraction. So we multiply the numerator together and the denominator together. So 1 times 1 times 1 times 1, this is equal 1 over 2 times 2 times 2 times 2 times 2, this is equal 32. Another example is okay. Took me a second. Can I move to the next slide?
Yes.
Okay. So the next slide, next example is the minus 3 to the power 4. What is that equal? We'll do it.
Like the calculator or
No, I need it like step like here.
standard. -3 times -3 times -3 times -3. 4 times.
How many times? Okay.
4.
Yeah,
4 times.
So 4 times we multiply the 3 times. So again, so negative times negative is positive, times negative is negative, times negative is positive. So the answer is positive. 3 times 3 times 3 times 3, they give me 9 times 9 is
81.
81. So the
81.
answer is yes, positive 81.
Yeah.
Yes. For the second example, if we have minus 3 to the power 4 without parentheses, what does that equal? Who will do this one?
Isn't it the same, or is it 3 times 3 times 3 times 3?
With the negative or without? I mean,
Not sure.
not sure. Okay, so for this one, we have to write the negative outside like this.
Without, right?
Yes, without. And you open a parentheses, big parentheses, and you multiply the 3 4 times. 3 times 3 times 3 times 3. So here's the difference, the negative outside. So 3 times 3 is 9, and 9 times 9 is 81. But we have negative outside, so it will be negative
Negative 81.
81. So after that, I find the negative 3 to the power 4 is not exactly the same like negative 3 to the 4. This is a sign question. So here is not the same, not the same. So negative 3 between parentheses to the power 4 is not the same as negative 3 to the power 4. The answer here is positive 81. The answer here is negative 81. Okay. Now, any question for this one? Is it
No.
clear?
Yeah.
Okay.
Yeah.
Now, for the 0 and negative exponent. So 0, 0, and negative exponent. Zero and negative exponent. Okay, so this have a definition, small definition. It says, definition says, if I have a number, if I have a real numbers, if I have a real numbers a not equal 0, and I have negative, I have n is a positive number, is positive, positive integer, not numbers, because when I said number, I mean all real numbers. So I have n is a positive integer. The positive integer is the same as the natural number integer. Then, so I'm going to define. So again, this is not equal here. A not equal 0. So this is not equal. A not equal 0. And n is a positive integer. Then I can define a to the power 0 is equal 1. Any real number to the power 0, they give me 1. So any real number to the power 0, they give me 1. So the answer here is 1. Okay, so also for the negative exponent, I can define a to the power minus n is the same exactly like 1 over a to the n. The minus here means we have to flip this real number. We have to flip this real number. And this real number is not equal 0. Why? Because I cannot divide 1 over 0. That's why here I said a not equal to 0. So I'm going to give examples for this.
I have a question.
What's
You know
your
how
question?
you know how you said for like after this class you're gonna post assignments?
Yes, I'm going to
Um,
post assignments for
we're
real
gonna find
numbers.
it on Blackboard, right?
No, in WebAssign. Everything in
what?
web sign.
On web assign?
Yes.
Okay.
So we have examples here. Example. So the example is find the value of number one. Thank you, Laila. Yeah, this is the class notes for all lectures. So you can find all lectures in this link. Thank you again. I mean, like our lecture. And also, I'm going to post the YouTube soon, maybe tomorrow, maybe in weekend. So here's 4/7 to the power 0. What is the answer here? 4/7 to the power 0.
1.
1.
Is 1, exactly. Look to this here, rules. Any real number, I mean for real numbers, is any fraction, because the fraction is a real number. Fraction, by the way, is rational numbers. So this is a rational number here, 4/7. To the power 0, they give me 1 by using this property here, this one, the red one. So any number to the power 0 always give me 1. Okay, next slide. Number 2. Here is number 2. X to the power -2. What is that equal?
Can you go back for like 2 seconds, please?
Yeah, sure.
Go back now.
Okay. So here, x to the power -2. What is that equal?
1 over
Yes.
x to the power of 2.
Exactly. So this is equal 1 over x squared. Why? Because when I see negative exponent, this is mean we have to put it in the denominator, or we have to flip this one. So this is equal 1 over x squared. Number 3, the question is -2 to the power -3. What is the value? We'll do this one. Yes, exactly. But here,
The 2 is positive, right?
the 2 is negative, and
Yeah,
we
but
have
we will-
parentheses. Yes, but we have parentheses. Is negative here.
Mm.
Here, Bernal, she answered the question, but yet she has to put the parentheses because, like we said before, the answer will be different without the parentheses. This one is different about this one. Exactly. So we have to put the parentheses. So this is equal 1 over -2 to the power 3 positive. And this is equal 1 over -2 times -2 times -2, -2 times -2 times -2. And the answer for this one,
1 over 8.
1 over minus, don't forget the minus, because -8, because minus times minus is positive, times minus, they give me negative. So it's 1 over -8, and you can write it as negative fraction, 1 over 8. Okay? Now, the rules for exponent. We have some rules. So the rules for exponents. Rules for So first rule is said, if I have a to the power m times a to the power n, this is equal the same base, see, but with different power. So we have to write it as a to the power m plus n. We do summation for the exponent. If the base is the same, we just sum, we do summation for the exponent, m plus n. So simple example for that, if I have 2 to the power 2 times 2 to the power 3, this is exactly 2 to the power 5. How we do that? 2 to the power 2 is equal 4, and 2 to the power 3, they give me 8. 8 times 4 is 32. And 8 to the power 5 is the same as 2 times 2 times 2, 5 times, and this equal 32. So the right side and the left side, they give the same answer. So this is right. We give both of them 32. Second rule, if I have a to the power m and over a to the power n, this is equal if the base the same things and we dividing two power with the same base, this is equal a to the power m minus m, m minus n. Example for that, the same things, 3 to the power 2 to the power 3 over 2 to the power 2, this is equal 2 to the power 3 minus 2, 3 minus 2. And the answer is 2 to the power 1, and this is equal to. Rule number 3 said, if I have a to the power m and everything to the power n, we do multiplication between m and n. So this is equal, here equal a to the power m times n. Example for that, 2 to the power 3, everything to the power 2. This is equal 2 to the power 3 times 2, and this is equal 2 to the power 6. Rule number 4. If I have a times b to the power n, this is equal a to the n. We distribute the power a to the n and b to the n. We distribute the n inside the parentheses. A to the n times b to the n. Example for this, example, 2 times 3 to the power, for example, 4. This is equal 2 to the 4 times 3 to the 4. Okay. We have can I move to the next slide?
Yes.
Yes. So the last rule is rule number 5. Here we have 5. Says a to the a over b to the power n. This is equal a to the n. We distribute the exponent also for the quotient, a to the n and b to the n. Example for this, I have 2 over 7 to the power 3. This is exactly 2 to the 3 over 7 to the 3. Any question for this rules? We have another one, small one. Number 6. Oh, I have 2 more. So So number 6 says if I have a to the b, this is very important one, a over b to the power minus n. This is very important. We have to flip inside the parentheses. This is equal b over a because we have minus. When you see the minus, we flip over n. And again, we use the same rule like number 5. We distribute the n. So this is equal b to the n over a to the n. How I know this? Property number 5. Here, prop number 5. This the property by using, we use it before. I think you use it here. This one, the flip, this one is called the negative exponent. So here we have negative exponents, so we flip everything inside the parentheses. Then we distribute, we use this property, number 5. Now, number 6 is, 7. I'm going to give example here before we move. The example says, if I have 2 over 7, everything to the power minus 3. So we distribute the minus, like we flip first. This is equal 7 over 2 over 3. Then we distribute the power inside the parentheses. So they give me 7 to the power 3 over 2 to the power 3. Make sense? And also, number 7 is very important too. If I have a to the power minus n over b to the power minus n, like minus m, different exponent. So here I have minus n, here we have minus m. So this is equal, we flip again. When you see minus, you have to go, the denominator goes down, the numerator goes down, denominator goes up. So this is give me b to the power m positive over here a to the power n. Small example for this. This example, 2 over 2 to the power minus 3 over 3 to the power minus 4. This equal 3 to the power 4 over 2 to the power 3. Okay, we're done by these properties. Any questions? All of them clear? No questions. Okay, let's give examples, general examples. No questions. Okay, perfect. So here we have examples. So the first one is x to the power 4 times x to the power 7. What is that equal? Who will do the first one? X to the power 4 times x to the power 7.
It's going to be x to the power 4 plus 7.
4 plus 7. What is the answer?
4 plus 7 is 11. So x to
11.
the 11 power.
Yes, exactly. So this is equal x to the power, here 7. We have 7. So here's 7. 4 plus 7. They give me x to the power 11. Number 2 is y to the power 4 times y to the power minus 7. Who will do this one?
Right, it would be y to the power of 4 minus negative 7 plus negative 7.
Yes, exactly. So it will be like y to the power 4 plus -7. And this is give me what?
Y to the power -3.
-3. And what is that equal? Negative power. What is that equal?
If you go back to the example, when it's negative exponent, we always do one. We always do a fraction, so 1/y to the third power.
Exactly. So this is 1/y to the third power. Thanks. Again, when you see negative power, we have to flip. It will be fraction. Example number 3. If I have c to the power 9 over c to the power 5, what does that equal?
It would equal b, and then we're gonna have 9 minus 5.
9 minus 5, exactly. So this is equal c to the 9 minus 5. We subtract. Why? Because we're using the property of number, this one, number 2. Same base, different exponent. Same base, different exponent. So 9 minus 5. And this is equal c to the power 9 minus 5 is 4. This is 4 here. C to the power 4. Okay, can I move to next slide? Okay, so another example here, number 4, example number 4 is x over 2, everything to the power 5. What is that equal?
It would equal to x to the power of 5 over 2 to the power of 5.
Exactly, so this is equal x to the power 5 over 2 to the power 5. And we can simplify this one by x to the power 5 over 2 to the power 5. They give me 2 times 2, 5 times, they give me 32. So this is the answer. Now, another example, simplify. Example, simplify. First one is for simplify, I have to collect, let me first writing the example is open parentheses 2 times a to the power 3 times b to the power 2 times 3 times a, b to the power 4, and everything to the power 3. For simplifying here, we have to combine the numbers together, the same letters to the same, combine the same letter to each other. So when you see something like this, first things, you distribute this power here, number 3, inside the parentheses. This is the first step. Then you try to combine the numbers together, multiplying the numbers together, and the same letters to each other. So let me do the first step here. Here I get 2, a to the power 3, b to the power 2, and who will help me for distributing the power?
Do you do 4 times 3?
No, I mean distributing the power inside the parentheses.
Mm.
How can I do it?
3 to
3
the
to the
power
power what?
3 to the power of 3. A to the
Exactly.
power of 3.
Times
And
a to the
then
power 3
for b you have to
b to
multiply
the
4 and
power.
3, right? So it's gonna be b to the 12.
Exactly. So this is exactly like this. And by using the properties, 4 times 3 is they give me 12. Okay, let me simplifying again. So I get 2 a to the power 3, b to the power 2, and 3 to the power 3, they give me what? 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27, yes. And here, keep it like a to the power 3 and b to the power 12. Now, I combine the number together. 2 times 27. So 2 times 27. Then I combine the a's together. So times a to the power 3 times a to the power again 3. And the last one is b. So times b to the power 2 times b to the power 12. And the final answer is 2 times 27 is 54, exactly. 54 times a to the power 3 times a to the power 3. So like I said before, we have the same base. And here also the same exponent, but the important things, we're looking to the same base. So we sum the exponent. They give me a to the power 3 plus 3 is 6 times b, same things. We have the same base, different exponent. 2 plus 12, they give me 14. So the final answer is 54, a to the power 6, b to the power 14. Any question for this one? Makes sense? Clear? Yes. Okay. We have another example. So the example now. So example. So x over y to the power 3 times y squared x over z, everything to the power 4. So what is the first step here? Who will help me?
Wouldn't you do x to the third power over y to the third power?
Exactly. So x to the third power, we're distributing the 3 inside the parentheses. So I get here x to the power 3 over y to the power 3. So this is the first one. And the second one, we'll do the second one, y squared. Again, distributing the 4 inside.
So wouldn't you do y to the 8th?
Y to the 8. So this is 2 and everything to the 4. And we're multiplying like before. 2 times 4 is 8. And times x to the 4, right? Here times, not x, is dot. Over what?
Over z to the 4th.
Z to the 4, yes. Now we simplify it more. So I get here, so when you see fraction multiplying by fraction, like I said before, we multiplying the numerator together and denominator together. So I get x to the power 3 times y to the power 8 times x to the 4 over y to the 3 times z to the 4. Now we're combining the similar to each other. I mean, for that, this is equal, here is equal, x to the 3 times x to the 4. And y to the 8 times y to the minus 3. Y minus 3 because I'm moving this one from down of the denominator to the numerator. So they give me y to the minus 3. And the other one is z to the 4. Again, I move it from down to the up. They give me z to the minus 4. Here I get the question. Can you post the link for the attendance? Anyone can post the attendance link, please, for him or for her? Thank you. So this is, they give me x to the power 3 times x to the 4. We do summation because we have the same base with different exponent. They give me x to the power 3 plus 4 is 7 times y to the 8 and y to the minus 3. Again, the same things. We have the same base, but different exponent. So we do summation. Y of 8 minus 3, they give me 5 times. The z is the only one, does not have anything. So you have to write it down again, down. So z to the power 4. And this is the final answer. Any question?
Yeah, just a quick question. If we wanted
Yes.
to keep as x to the 7 times y to the 5th over z to the 4th power, that would be fine, right?
But the question is, ask you to simplify. I mean, for simplifying, you have to write it like this, in the simplest way, like this. But if the Wobble sign, they told you you can write it as without negative exponent. Sometimes in the Wobble sign, they ask you, write the answer without negative exponent. This is mean when you arrive to this step, just you have to write this one here, z to the minus 4, because we have negative exponent. You have to write it in the denominator. So if they ask you, don't write it in negative exponent. Just when you arrive to this step, you have to write it like this, equal x to the 7, because we have positive exponent, times y to the 5, we have positive exponent, and here we have to change it from negative exponent to positive exponent, would be as z to the power 4. Make sense?
Yes, thank you.
Okay. Now let me give you another example. So here is example. Again, simplify the expression. The expression. So the first one, a 6s times t to the power minus 4 over 2s minus 2 t to the minus 2. I mean to the 2. Okay, who will do this one? Again, we combine the numbers together, same letters to each other. We'll do this one. Okay, I'm going to do it. So the numbers here, we have to work each other. Oh, for everything, I'm going to move every thing times 3 times 4 times so I'm going to give it to generator. Here I get s to the power 2 positive because I move from negative to positive times t to the power minus. So I'm going to combine all the numbers together. So I get here 6 over 2 times together, and the last things I here left is t to the power minus 4 times t to the power minus 2. Now is easy, right? So 6 over 2 is 3 times s to the power, because we have the same base. Here s to the power 1, here s to the power 2. So 2 plus 1 will give me 3 times t to the power minus 4 minus 2 is minus 6. So again, if the question told you don't write the answer as in negative exponent, so you have to move this one to the denominator. So this is equal 3 times s to the power 3 over t to the power 6 positive. Is it clear? Makes sense? I'm going to give another example. Okay. So another example here. So example B, simplify y of 3z squared. Who will do this one? Any idea or any, how can I start for this? Here we have negative. So how we can start?
Distribute -2 to everything.
This is correct.
Wouldn't we have
But first things we have to do something before we distribute the -2.
we would have to flip it like 3z to the second power over y,
And
and
everything
then have it
and everything to which power?
the power of 2 instead of the negative.
Exactly. So I'm going to use this property here, this one here, this one. Number 6, a to the power b, everything to the, then I distribute because it will be more easier. So here by using 6 fifth property, I get 3 to the power z and times z to the power 2 over y, everything to the power positive 2. So instead of negative, become positive. Now, this is equal, this is equal, here we distribute the 2 again. Can you go to the last slide? Yes, I will go after I finish this one. So again, we distribute the 2 inside the parentheses. So I get 3 to the power 2. Why did I flip? Because the negative. Because we have negative. We have negative, we flip everything inside. Ryan. Because we have negative by using this property, number 5. Number 6. A over B, everything to the negative n, we flip inside and we keep the n positive n. Okay, Ryan? So the same idea here. When you flip, we get rid exactly of negative. That's true. So we remove the negative. Now I can distribute the 2 inside the parentheses. I get 3 over 2 times z to the power 2, everything to the power 2, over, and the y to the power 2. Now I can simplify this one because 3 to the power 2, they give me 9 times z to the power 2 times 2, they give me z to the power what? What's the answer? We multiply. What's the answer? 4, exactly. So z to the power 4 over y to the power 2. If the question told you, don't write the answer as fraction, so just you move the y to the power 2 to the up. How I can move it? 9 times z to the power 4 times what?
Times y to the
Y
negative.
to the negative 2.
Exactly, y to the negative 2. So this is the simplest way to write the fraction. Okay. I'm going to give you another example. Make sense here? Any question? Okay, this is the example here. Can you? Oh yeah, I can go back. Yeah, sorry for that. This one, right? This slide or the previous one? Yes. Okay. Okay. You're welcome. You can go back now. Okay. So another one, another example, the same things, because this is very important. You will see a lot of examples in web design for simplifying, and also in the exam too. So the question now, okay, a to the power 4 times b to the power minus 3 over b to the power 4. This is easier than the previous one, than b. Same idea. Who will do this one? Again, we combined each letters together.
You would combine b to the 4th
B.
to the numerator.
Okay, what is the answer?
I guess it would be B.
B. So what about A now? What I have to write here? So I keep the A, right?
Yes, you keep the A.
So A to the power 4.
And then you put, I guess, B to negative third power
Negative 3 times what?
times B to the fourth power.
But we move
Actually,
this
does
one
that?
from denominator to the up.
Yeah,
No, negative, right?
yeah.
We move from down to the up, we change the sign. So it would be negative. Now, what is the easiest? What's the answer
It would be A to the
after we
fourth
simplify? Okay,
times. Would it be negative 7?
negative 7. Exactly. This is the answer.
Okay.
Thank you. Yeah, correct. So the answer is A to the power 4 times B to the negative 7. Again, if the question told you don't write the answer in the negative exponent, just you move this one to the denominator. So you write it like A to the power 4 over B to the 7, like this. Any question?
So for the final answer
Okay,
in
another
part
one.
B, we have a question.
Part B, this one? Yes.
Yeah. So do you want us to leave the answer like that, or do you want us to simplify it more?
I need it in this way, in the negative. But sometimes in the question
You
they
don't
told
want
me,
us to
they
connect
told
it?
you, yeah, I need the answer in this way, like this. But if the question specify what's the answer they need, sometimes they told you don't try the answer in the negative exponent. So this is negative exponent. So you don't have to write it like this. You have to write it like that. This is, we don't have any negative exponent.
Okay,
We see
so-
here z to the power 4, this is positive, y to the power 2 is positive. But if the question does not specify, you have to write it like this. Here, 9 times z to the power 4 times y to the minus 2.
So I have to always write the multiplication sign and not connect
Yes.
them. Like, okay. Okay,
Yes.
thank you.
No problem. Another question? Okay, we have another example. This is ABC. ABC. Now we have D. The example is, okay, here, z to the power 2 times z to the power 4 over z to the power 3 times z to the power minus 1. Who will do this one or help me what I have to do? Give me the steps. So all of them z. I have to combine all of them. So what I have to do here?
Okay, first you write the top and then you move the denominator into the numerator. So you can do z to the power of 2
Z to the power 2
and,
times,
times z to the power of 4
okay, times,
times z to the power of negative 3
exactly,
times
times
z to the power of 1.
1, positive 1.
Yes.
So now we have the same base, z, z, z. So what I have to do, we just adding the exponent together because we have the same base, different exponent. So 2 plus 4, they give me 6, minus 3, they give me 3, plus 1, they give me 4. So this, the answer is z to the power 4. So all this is equal z to the power 4.
Can it not be done into another way?
How you can do it in the other way?
I did another way and I got the same answer.
How? Can you
So
tell me
first
how?
I did z for the numerator. I just did 2 plus 6 plus 4, which is 6. So z
Okay,
6.
hold on. So you write z to the power 2 plus 4, they give you 6, right?
Yes.
Okay,
And
then
over and z minus 1 plus 2.
yeah, z 3 minus 1 is they give you 2. Then
So since it's a division, I just did z 6 times minus yeah z 2.
2.
And I
Yeah,
get
this is
that 5.
correct. Yes, this is correct too. So we have two different way. This is second way. This is correct. And this is the first way. So we can combine the numerator together, combine the denominator together, then we combine everything together, the numerator with the denominator. This by using the property in the previous. We have the same base with different exponent. So this is equal z to the power 6 minus 2. They give me 6 to the power 4. Another example here. See, f minus 2 times z to the power 4 and everything to the power 3 times 4z to the power 3. Who will do this?
First, you
Again, we
have to
have to
distribute.
distribute the 3 inside the parentheses. Yes, what I get here?
What do you get? -2 to the power of 3, and then z to the power of 12,
Okay,
and then parentheses,
z to the power 4 times 3.
and then everyone just
Okay,
stays the same, 4 z to the third.
okay, thank you. This is correct. Now let me combine the numbers together. -2 with a 4. So -2 times number 4 and the z's together. Here we have z to the 4, everything to 3, they give me z to the 12 times z to the 3. Now what's the answer? -2 times 4,
-8.
-8. And the z, 12 plus 3, because we have the same base, different exponent. 12 plus 3, 15, right? Why did not we
Wait, sir.
yes,
Um, like somebody also mentioned, what about because I remember you said that if it's in the parentheses, like you see like the parentheses -2 to the square of 3.
oh sorry,
Yeah.
this is correct, sorry. Okay, so here we have 3, we have here 3, sorry for that. Here -2 to the power 3, here's to the power 3. What is -2 to the power 3? -2 times -2 times -2, they give me -8. -8 times 4, and the same things here. Z to the power z to the power 12 plus 3, 15. Now -8 times 4 is -32 times z to the 15. And this is the final answer. Thank you. Any question? Okay, the last one before we end the class. The last example. Can I move to the next slide? Okay. So the last one is number Z. So the question is simplify again. 7 times x to the power minus 5 times y to the power 3 times 6 zx to the power 4 times everything square. We'll do this one. Again, combining numbers together. First of all, we have to distribute the power inside the parentheses. So who will help me for that?
For the
Distributing
first,
two. Yes. Go ahead.
so for the first set, it just stays the same, like 7x to the negative fifth, and then y to the third stays the same. And then it would be 6 to the second power, and then x to the 8th power.
X to the 8th power, exactly. Thank you. Now combining the numbers together and the same letters to each other. So I have here 7 times 6, this 6, and x to the power minus 5 times here x to the power minus 5 times x to the power 8, and the last one is y to the power 3. So the answer now, 7 times 6 is
Is it not 6 to the
I think
42,
you forgot
right?
to do the 6. For the 6, the second for the 6.
6 square. Again, the same wrong. Sorry for that. So here 6 square. I mean, because okay, so 7. So 7 times 6 square. 6 square is 36. So 36 times 7. 7 times 36. How much? 7 times 36. They give you 200. Give you 252. So I get here 252. And for the variable x, I get the x to the power minus 5 plus 8, because they have the same base, different exponent. So 8 minus 5, they give 3. And for the last variable is y. So we keep it the same things without changing. So the final answer again is equal 252 x to the power 3 and y to the power 3. Any question? Make sense? Okay, so we're going to stop up to here today, and I will see you next week, Monday. Have a good day.
Monthly.
Bye.
Um,
Next, yes. What's
So-
your question?
Supposedly they said that there was going to be like some sort of break and we're going to